All right, good morning, everybody. Welcome to AWC's bi-weekly webinar, where we cover the key technologies of water and wastewater treatment, as well as, cover key technologies and challenges of the water and wastewater treatment industry. My name's Ryan Harvey. I'm filling in for Alex Piscini today, and we are joined by Alex Simon of Ramtech Environmental Products, who will be covering open channel wastewater UV systems. Good morning, Alex.
Hi, thanks for having me.
Yeah, of course. UV, as we know, especially on wastewater, is important during this COVID era. We've covered UV a few times in the past, but never wastewater and never specifically open channel. Let me just jump to the next slide here. Quickly, first of all, just a brief overview on AWC. We've been in business for over 40 years. We do have all of our design and fabrication in-house, and we've built over 600 plants globally. We've got a wide range of water and wastewater treatment technologies, ranging from conventional membrane and ion exchange on the water treatment side of things to MBR and MBBR on the wastewater side of things. And with that, I will pass it off to Alex.
All right, let me just share my screen. Let me know when you can see that. Can you see this right?
There we go. Yeah, looks good.
Oh, awesome. Thank you for having me. So yeah, my name is Alex Simon. I work for Ramtech Environmental Products. We are a proud representative of AWC and of Trojan UV disinfection. And that is where most of this information would come from. There are lots of UV manufacturers out there, lots of them that do open channel UV, but let's dive right into it because I know we're keep this short and sweet. So let's go through some very, very UV basics. What is UV light? UV light, I mean, this is the UV light spectrum, or sorry, the light spectrum. You got X-rays on the left, very, very short wavelengths. They're used in hospitals, your visible light from 400 to 780, and then infrared above that. UV is down in the middle there. UVC is what we're most interested in. That is called the germicidal wavelength, and specifically at 254 nanometers. The 250 nanometers is the wavelength that is most effective at interacting with the DNA of a microorganism that we are looking to disinfect. And it actually gets into the DNA, fuses a couple dimers together, and keeps it from reproducing. And we say kills, but in reality, it's just inactivating them. It's not necessarily killing them, but it is keeping them from reproducing and causing harm. What is the core of any UV wastewater treatment or water treatment system? It is the lamps. So the lamps are what output the energy, and the goal is to put out as much energy as we possibly can at 254 nanometers. There are three main types of lamps used in wastewater right now. Low pressure, low output. So that was developed in early 2000s or so, early 90s. Very small systems, low amounts of energy. I mean, 87 watts per lamp. They are light bulbs, but they are outputting at that 254 nanometers. Low pressure, high output, and when I say pressure, I mean pressure within the lamp, not within the UV system. I mean, open channel, so there's no pressure, but it's within the lamp itself. They are very the low pressure, high output, or LPHO, are about 180 to 1,000 watts per lamp. They're very flexible. They have a very specific output at 254, and they are very, very efficient because of that. Medium pressure, that is more used in drinking water, and it was used in wastewater quite often through the 90s and early 2000s because that's the technology we had at the time before the LPHO lamps came out.
Hey, Jason. Sorry to interrupt. There's sort of some gray blocks that kind of seem to be blocking your presentation just a little bit there. Can you maybe just try unsharing and resharing? Oh, there you go. Yeah, whatever you're doing there is working.
I hope it wasn't blocking any of the important parts. No, I think we got it down. Sorry about that.
There's still one in the bottom right there.
That is your picture.
Weird. Yeah, I think you can move that. There you go. Yeah,
so
much better.
I've never given a presentation on Teams before, so thank you for letting me know. Medium pressure lamps, extremely high UV output, with 3,200 watts per lamp for some of them, and they're very, very powerful, but very, very inefficient. This is the actual output of what a medium pressure lamp is giving. Remember we mentioned 254 nanometers, and I believe you can see my cursor. That's right here. So that is a large amount of energy being put out right at 254, but you see all these spikes above and below 254 nanometers. That's all energy, and it is able to disinfect something, but not nearly as effectively than 254 nanometers. So that's a lot of wasted energy. Low pressure high output, on the other hand, that's a single spike at 254 nanometers, almost all of the energy right there, and then a little spike below that at 190. That's why they're so energy efficient, because almost all of the energy being produced is right there at that germicidal wavelength. So the core of sizing any UV system is the dose. What is the dose we need? So UV dose is simply UV intensity, so how intense those lamps are, multiplied by the residence time, so how long that water spends in a UV system. This is a drinking water reactor shown here, but it's the same sort of thing. Sorry about that. The best analogy I can give for this is a sunburn on a sunny day outside. So if you go outside and there's no cloud cover whatsoever at high noon, and you're out there, you can burn within 5 minutes or so for some people. But if it's a really cloudy day, you might still burn, but you can probably be outside for more like 2 hours or so. So you can still get disinfection with lower intensity, but you have to leave the flow, the water in there for a longer period of time to get the same amount of energy. And dose is expressed in millijoules per centimeter squared. UVT is the other important sizing parameter, is often overlooked, but it is 9 times out of 10 when we see issues with plants, it's because they've misunderstood what their UVT is. So UVT, transmittance, is the amount of UV light that can pass through 1 centimeter of water. Very simply, we fill a small cuvette with 1 centimeter of water, put a UV light on one side, a sensor on the other side, shine it through, get the percentage that makes it. That's it. And then that percentage is what we use in our sizing tools. For wastewater, I mean, it's very difficult to predict because every plant is different, but lagoon wastewater, 35, 40%. Secondary effluent out of a secondary clarifier, for example, 55%. MBR plants, 65 is what we usually assume, although we see considerably higher than that often, but we always size on the worst case scenario. So for MBR, 65 or so. Lots of other examples there too. This is just one of my favorite photos, is to show what low UVT can do to a UV system. So this is actually a drinking water system, but it's the same principle. On the right, you have sleeves that have been cleaned by this wiper. It's just a mechanical screw-driven EPDM or Viton sleeve, or ring right on the sleeve. So that's cleaning it you can change the interval, but probably every hour or so. And on the left there, that's the very end of the sleeves where the lamps are not located, and that's not cleaned. So you can see how effective wiping system is. And if you don't take what fouling can happen into consideration when you design a plant, this is what you can end up with. It can really impact the amount of UV intensity that gets out into your water. When I am sizing a system, I want to know what the peak hourly flow is. I want to know what the disinfection target is. So if you're looking at less than 200 fecals, for example, you can tell me that, and then what your process is. And based on the UVT, I will calculate what dose is required to meet that. And I can let you know what that is, and you can put that in your spec. So let's go through some fun stuff. Let's talk about some examples. This is generally what most all open channel UV disinfection systems look like. There's lots of different configurations that I'll show you, but generally this is a good overview. You have the lamps here hanging down into the flow. Those lamps are surrounded by sleeves that are covered by a wiping system there and here. There is light locks here to prevent the UV light from getting out to protect the operators. These are called, each one of these is a module. In here, there would be a number of ballasts, 4 in this case, that modulate the power of the lamps. This power distribution center is distributing power to those ballasts. There's the control panel there, or it could be its standalone. There's a hydraulic wiping system for those for the wipers. Some are driven pneumatically, some are driven by screws, just based on manufacturer. You'll have a level control system here. This is a weighted gate. There's also finger weirs, which are really simple, or even just a gate holding in the water at the right level to keep the lamp submerged. But look at this. For this specific example, if you have a weighted gate and the flow goes to 0 and the gate is not heavy enough, it will not close all the way. There will be a small leak. And you'll see the top couple of lamps get exposed. And then when they restart, they're in air and they could burn out. So just talk to your manufacturer, explain the system that you're looking to install, and we can make the correct recommendations. This is, remember I mentioned medium pressure lamps. Well, this isn't something that is sold anymore. It was discontinued many years ago, but I wanted to show it just because there's still some examples out there. A lot of metal, a lot of lamps, a lot of power, very expensive, very inefficient. So we have moved away from this, and most of them are being replaced over the years. Just some flow goes in here. This is where the ballast are, hangs down in the flow. It's on both. It can be on both sides, and out it goes. Very simple. This is the newer replacement for that kind of system. This is called a Trojan UV Sigma. It is actually an angled installation as opposed to the horizontal one we showed earlier. The open concrete channel, chemical mechanical cleaning system. It can handle a massive range of flows, and it can be controlled many different ways. This is nice because this shows one bank raised out of the channel, so it's nice and easy for an operator to be there and work right at it, raised out of the channel. This is like taken out. So any sleeve, any lamp changes you need to make can be done right there at chest level. You don't need to go in and pull a module out. It's much simpler. This is the bank itself. There's your power distribution centers, your hydraulic control system. This is also driven hydraulically and raised and lowered hydraulically. And there's your controller. I can actually show you this. I think you can see my screen, but this is what a wiping canister would look like. Simply a wiper, put in a holder. This is filled with basically CLR that is sealed together. It's one on each end, and this just moves from one end of the sleeve to the other and helps keep them clean. This is the 3000 plus, the Trojan UV 3000 plus that we showed earlier. It is horizontal lamps now, still the LPHO, so very efficient. Open concrete channel, same chemical mechanical. This is more like 3 MLD and up. Sorry, we're in Canada, so I used MLD. This is an example of what it would look like if the channel was empty and you were standing downstream of it. So here's you got all your modules here. Each one is holding 8 lamps down. Each one of these here is a lamp. And I'm not sure if it's shown here, but one of these middle modules, yes, it is shown here. So this middle module probably actually has 9 sleeves, and one of those sleeves would have the UV sensor in it that is detecting how much energy is being outputted by this whole bank. And it can be used to monitor how fouling is doing on the sleeve, because even if you have chemical mechanical, it's going to need to be cleaned manually every once in a while. And it can be used to modulate the output of the lamps. These ones specifically can go from 100% peak down to 60%, depending on what you need. This is the support racks here that hold the weight of all these modules, and you can actually walk on these. I'm a very big person, and even I can walk on them. So this is just an example photo of one of those modules pulled out. So you can see why the newer generation systems like the Sigma are looking at those angled lamp systems. Now it does make for a deeper channel, but much easier to take care of, and the lamps in that system are much more powerful, so you need considerably less. You can see the UV light, the green there, that's coming out a little bit. If you're doing maintenance, you don't want to be staring at that a lot. That's why we have this here, that's called the light block. Keeps that UV light from reaching out, so always wear your eye protection and everything when you're doing maintenance. And the last thing is small water systems. So we've talked about the biggest ones, like I'm talking for City of Calgary, Edmonton, Vancouver. Those are all using those types of systems, the really large ones. But if you're talking for a small resort, this is what you're going to be looking at. This is called the Trojan UV 3000 PTP. So PTP is package treatment plant. Much smaller system, looks very similar, same configuration with the modules, or sorry, the ballasts held above the UV system and hanging lamps down into the flow. Usually there's no cleaning because these are the LPLO, so low intensity lamps. They're about 85 watts each, so they don't generate a whole lot of heat, and heat is what is pulling your the fouling material out of solution in the wastewater and onto the sleeves. So for a small system like this, a wiping system almost turns into its own maintenance issue. So it's just much easier to clean these by hand. Each module is 30 pounds. The last one I showed is more like 100, so you can lift it with a couple people, but don't drop them as I have done because it's very expensive. In this, you can see there's usually transition boxes on the end here, but you can see the little weir in the channel holding flow right at about this level here. This is an example of what one would look like installed in the field. So you have flow coming from the right into the stilling well, hits here, comes up through the channel, hits that weir we showed. All the modules are hanging down. I think there's only 2 or 3 in this one, so it's a very small system. And then out into the next transition box and out. We can have these in many configurations. You can line 2 channels up, one after the other, or side by side, or even do a U-turn. So the inlet's here, turns back, comes back the other way. Really simple, relatively cheap, and it's a good solution for small plants. It's also very nice because of the low pressure, low output lamps are not as hot. You can leave them on when flow goes to 0. So it's really nice for an SBR, for example, commonly used after that. So that's all I have for now. Very broad overview of wastewater treatment, UV and open channels. If there's any questions, please let me know.
Great, thanks for that, Alex. It does look like we have a few questions coming in. One of them is from Anvar here. In one of the slides for large wastewater plants, the capacity was mentioned as 3 MLD and up. Sorry, Anvar, can you maybe unmute your mic there and maybe just ask that question? I'm not sure where you're going there.
Oh, I do.
Thank you, Ryan. It was like, what is the upper limit of this until from 3 MLD until what?
Well, the upper limit is not defined by the UV system; it's defined by economics. We can treat any flow you want with a UV system, but eventually it's getting massive. So a lot of times they will, and that like an entire plant's flow does not need to be treated for the permit. So we'll usually take a subset, or only seasonally we'll treat the UV. So there is no real upper limit. So if you've got a 500 MLD plant, I'm happy to treat all the UV or all the effluent from it.
Great. The next question is, what would you take into consideration to decide whether or not to use open or closed channel UV?
Yeah, good question. So again, just for time, we didn't get too deep into, or deep at all, into closed vessel UV. It is really effective if you want to maintain your pressure. So if you have an MBR plant, we often see closed vessel UV systems installed at the end of MBR plants, just so you can keep that pressure going right to your discharge. And the effluent from an MBR system is really good quality. So you're not going to foul the internals of a closed vessel system as much. Now, if you're looking at a lagoon, which has 35% UVT and really high TSS, you're putting that through a closed vessel reactor, it's asking for a maintenance issue, and it's going to add to a significant amount of issues down the line. So it really depends on your application, but MBR, yeah, I really like closed vessel UV for that. The Trojan's one is called the Trojan UV FIT, F-I-T. It's filtered inline treatment. Filtered is the keyword.
Okay. Another question would be, how do you determine what dose to use?
That is site specific. So if we're given the disinfection targets by the local health authority or whatever. So in Alberta, it's often less than 200 fecal coliform per 100 milliliters. We'll take that, and we know based on bioassay testing that we need about a 30 millijoule per centimeter squared dose to meet that on those PTP systems. Larger ones need less. So over the years, Trojan has gained a broad experience of tens of thousands of water samples from all plants across the world. And they can look back at that database and calculate, based on your process, what dose we want to deliver to meet your distribution targets.
Okay, sounds good. I think one last question here before we call it here. How often do the sleeves need to be cleaned?
That is also site dependent. It really depends on what your process is. So on an MBR system, if it's going to an open channel, that's very clean water. It's not going to be very often. And if you have a chemical mechanical cleaning system, you might be looking at every 6 months, maybe once a year. But if you have a lagoon with really low UVT going through an open channel UV system, even with a chemical mechanical wiper, it's not going to be able to keep up with it. And you're going to have to pull out the sleeves and clean them manually, maybe every month, 2 months. It's very site dependent. But that's why we like that horizontal or angled lamp system that you can lift up. Just raise it up and clean it right there without having to do or anything involved.
That makes sense. Okay, I think we'll wrap it up there. Anybody who wants to stick around can ask questions after we stop here, and feel free to reach out to Alex or myself at any time. And stay tuned for webinar number 30 next week. We're going to cover MIAX, which is a magnetic ion exchange technology that's particularly good at targeting organic removal. Also, please check out our YouTube site. We have a lot of topics we've covered in the past, and there's a lot of good information there. So thanks for joining us, everybody. Take care.
Okay, thank you.